Alright, so we're going to talk about 4.6 part 2, the location principle, guys. You don't have really any specific homework on this. You do have like that homework quiz. Okay.
It is on the
This
test.
this is on your test. It's on your practice test as well. Okay, so you got to make sure you have really good notation. The concept is really easy. It's going to really come down to your notation. All right, so this is our lovely location principle. So, guys, make sure that you're actually writing this down. If f is continuous on the closed interval AB, okay, so it's going to be really the same as IVT, right? And f of A and f of B have opposite signs. What that's really saying is our outputs, okay, for A and B, have opposite signs, saying one of them is going to be positive, the other one's going to be negative. If that's true, then f has at least one zero between A and B. So, if I were to draw a picture here to help explain this. Yeah, so let's say this is A, this is B. F of A we're going to make positive, so I'll say that's up here. F of B is going to end up being negative. Okay, so guys, if this is continuous on the closed interval, for you to go up here to down here, wouldn't you have to cross the x-axis at least once along the way? Okay, if you're continuous, there's no other way for you to go from here to here without crossing the x-axis. Okay, it might just happen where it goes nicely down like that. Okay, other options it could look like though. Could have lots of crazy stuff going on. Okay, maybe it just goes way up here and then all of a sudden comes down. Last second, it still crosses the x-axis. Other things that could be going on. Okay, notice this says at least 1, 0, so it could be more than 1, 0. So other options are as it goes down and comes back up and it goes back down. So we would have 1, 2, 3 here. Okay, you could cross it really infinitely, almost infinitely many times. But there must be at least one x-intercept, really. So that's really all it's saying. You want to add anything to that?
So really this is just a spin-off of the intermediate value theorem, right? Because the intermediate value theorem has the same hypothesis, which you have to state. Both Hernie and I award 2 points on your test, or take away 2 points on your test if you don't say that your function is continuous, and how you know, because you know what kind of function it probably is, and you're stating that. That's why we do continuity before we do this section. And one thing that confuses kids a lot on this one is they think they're finding the zero or zeros, because you're not finding the zeros. It's an existence theorem. You're just saying there has to be one because you have these opposite signs. So you're not finding the zero. You're just kind of like proving that there has to be at least one.
Yeah, so I just drew it where now it's the opposite. So before f of A was positive, f of B was negative. Okay, now we got f of A being negative, f of B being positive, but you still have opposite signs here, which is the most important thing. So you must cross this x-axis at least once to go from here to here, if you're continuous. Okay? A couple other things I want to talk about, though. So if we got A and we got B, okay, we have f of A. Yeah, we'll say f of B is down here. Alright, so now we're both positive. So if they have the same sign, your outputs have the same sign, does that mean there's no x-intercept between A and B? Well, can our graph go down and then come back up? So you could actually have two x-intercepts. So just because your outputs don't have opposite signs does not mean that there is not an x-intercept there. But if your outputs do have opposite signs, it guarantees that at least 1, 0 must occur on that interval. Okay, we could also even just have 1, 0 here. Bouncy, bouncy. Yeah. So it's just one thing to keep in mind. Just because they have the same signs does not guarantee that there's not an x-intercept. But if your signs are opposite, it is guaranteed that there must be at least 1, 0.
As long as you're continuous.
as long as you are continuous. Cool. So let's get into doing like a problem that's going to be on your homework quiz. It's going to be like on your test. Okay, so basically all you're going to do is really find or verify. You're really going to verify that A0 must exist. Okay. So let's write some words down because we love words. Verify that the function. Okay, I'm not going to give you that dumb notation. We'll just say P of X.
Mr. Herney!
Hate that notation. Don't waste my time with that notation. Alright, so verify the function P of X. That's P of X has at least 1, 0 on our interval 3 to 4. Okay. So let's begin. So guys, just like when we're doing our IVT, okay, location principle is basically the same thing as IVT, right? You can't go from point A to point B without crossing all of those y values in between. So we're going to have to do a hypothesis statement. Okay. So the hypothesis statement is going to be very, very similar to IVT. Okay. So it's going to begin with P is polynomial and continuous everywhere. Okay. P is polynomial and continuous everywhere, and therefore continuous on our closed interval 3 to 4. So guys, if that's true, IVT holds true. Okay, location principle is going to hold true as well. So what we're also going to have to do is figure out our outputs for 3 and 4. Okay, I'm just going to add on to this. P is polynomial and continuous everywhere, therefore continuous on that. And do we want to put end location principle holds true here, or do we want to have them figure out our outputs first?
No, I would say location principle holds true first.
Okay. And location principle holds true. Okay, so now what we're going to want to do is figure out, well, what is P of 3 and what is P of 4?
And before Mr. Herney does that, you guys, you better not be looking at this and not realize that it's polynomial. Like, tell us you know, right? Tell us out loud. We want to hear it, right? That you know this is a cubic, that it's a positive 2. So the ends would be in opposite directions because you have an odd degree with a positive coefficient. So the more and more you go right, the more and more you go up, the more and more you go left, the more and more you go down. You could write that with limit notation. And then your y-intercept is at 10. Like, you better know some of those, like, sharp characteristics about any kind of, especially polynomial, instantly, even if it were, like, something that we weren't doing on a calculator. Okay?
Alright, so we're going to figure out what P of 3 is. Now, guys, we're going to show you how to do this in your calculator. You can use the calculator on this test. So, I'm going to write in y1 2x cubed minus 7x squared minus 3x plus 10.
So
you go into y equals, you type in your equation.
Looks good.
Okay. So then you can quit out of that, and what you're going to want to do is y1 and then parentheses of 3, and then y1 parentheses of 4 to get what these values are going to be.
So remember, when you're doing this, it's like function notation. So when I do y1 and I go ahead and put in my parentheses myself, it's like saying f of 3, or in this case, p of 3. And maybe Mr. Herney would still write down all of the 3's replacing every x, even though he's just going to have his calculator do the arithmetic. And maybe all of the 4's on the next one replacing all of the x's, even though we're making the calculator do the arithmetic. So we got negative 8, Mr. Herney, when we plugged in p of 3. Remember, to get that y1, you do alpha trace, so your green alpha button and the fourth function button. So there's the y1, it pops up on your screen. Now we're going to put in the next integer, which is 4. And when we do that, we get 14.
Sweet, they have opposite signs.
And
then who would have thought?
Conclusion.
Okay, that doesn't mean we're all done though. What you do need to talk about is that these do have opposite signs. Okay, therefore there must be at least one zero between 3 and 4. So let's just say that P of 3 and P of 4 have opposite signs. Therefore, at least one zero must occur on our interval 3 to 4 on x equals 3 to 4. Alright, that's really it, guys. We're not asking to find out what that zero actually is. We're just asking you to verify that there must be a zero in between whatever interval we give you.
So we know that this is true because it's continuous everywhere. So we have to hit that output of 0 because it's really IVT. It's just a spin-off in particular about hitting the 0 for your output. When we were talking about the homework, you guys, we're going to take off the location principle homework because we want you to do the homework quiz and then just concentrate on your practice test and getting prepared for your test on Friday. So you're only really going to get like one problem that has to be perfect notation, one problem on the practice test, and then you got to be able to do it on the real test. It's not a lot of math. It's a lot of like, do you know some good words?
Alright, I just plotted these 2 points. Guys, just from knowing that P of 3 is negative 8 and P of 4 is 14. Okay, that's kind of what this looks like. This is a polynomial. Okay, our y-intercept of that polynomial is 10. It's not really necessary to talk about that, but it's good to just always go over this. Okay, think about our end behavior. We must be going up to the right because our leading coefficient's positive. Our degree is odd, so our left must be going down. So our graph's really going to look something like this. Okay, that'd be my guess on how this graph's going to look. But what we're really saying here is we were negative down here, we are positive up here. If we're continuous, you have to go through the x-axis at least once. Okay, and that's all you're really showing and talking about.
And make sure you have that phrase at least one, because there could be more than one.
Alright, let's do another one of these.
Okay, Mr. Herney, you have to use the funky notation.
No.
Yes!
I refuse.
Come on. You can...
I don't even know how to do it off the top of my head.
I'll do it. Here, I'll write it for you.
Oh, alright.
You Sally. Okay, we're verifying that the function f, where every element of the domain is assigned to, remember how this one goes? X to the 4th minus 6x squared plus x minus 3 has 2 real, remember the symbol for real numbers, you guys, the like capital R with the extra bar, has 2 real zeros located between consecutive integers. So we have words going on all over Mr. Herney. So we're going to erase this part.
There's more words?
No, that's it.
Good Lord. Alright. So, glad you took all the time to write that down, because the first thing I'm going to go back and do is say f of x equals x to the 4th minus 6x squared plus x minus 3. Because that's how normal people do this stuff. Has 2 real zeros located between consecutive integers. Alright.
So
what do you want us to do on this then?
Okay, so let's start the same way we started last time, right? Talking about the fact of the hypothesis statement. So what kind of function is f of x, Mr. Herney?
F is polynomial.
And what do we love about polynomials?
They're continuous everywhere.
But here's the thing, you guys. We don't have the closed interval to say, therefore, we're continuous on the closed interval. Most of the time you do, but we're just trying to make you think about like another approach to this problem. And so that you understand the word consecutive integers, I've seen like some of those big vocabulary words on PSAT and SAT stuff. So consecutive, doesn't that mean in a row? And integers means positive or negative whole numbers. So if we thought like we were on the last problem was a cubic, we had our ends going opposite directions in an increasing manner. Well, this is a poly, but it's not a cubic, it's a quartic. So if we just thought like the general shape of the graph, it's a even degree, the y-intercept is at -3, and when at both ends go up, because it's a +1 as the leading coefficient. So that would be our end behavior. We could even write the limit as x approaches infinity of f of x, because you got to take the limit of something, will go towards positive infinity. The limit as x approaches negative infinity of f of x would have to go towards positive infinity. But maybe we like don't know much else about this because it's not like in transformation form or factored form. Well, let's use our calculator to help us maybe get a little bit of a narrowed down idea of where the zeros might be. So here is our f of x function in y1. So there's the x to the fourth. We don't have a cubic term. Minus the 6x squared plus x minus 3. Probably just a normal standard window will be sufficient. And then we're going to hit our last function button, which is our graph button, and look at it. But we're not surprised by what we see. Oh, look, there's our y-intercept. Oh, look, it looks like a W with both ends going up. And if we kind of zoom in a little bit, do you like how I'm zooming in? It looks like we might have a 0 in between -3 and -2. And it looks like we might have a 0 in between +2 and +3. And in interval notation, we would have to go from smallest to biggest. So now that we have more of an idea of what the graph looks like, then now we can add to this. So f is a polynomial continuous everywhere. Therefore, continuous on this first closed interval, which are consecutive integers happening in a row, -3 to -2, and continuous on the next closed interval from +2 to +3. Remember, we're not finding the zeros. That's not the point. We're proving that they're there.
Sweet. So, therefore, location principle holds true.
So this one's about proving the opposite sign thing, and IVT is about finding C, right? So f of C equals m.
Okay, so we got to figure out a couple different things here. We got to figure out, well, what is f of -3 and f of -2?
So since I already have my rule in y1, I'm just going to do y1 of -3 on the home screen, which gives me 21.
Y of -3 is 21?
Yes, f of -3, or y1 of -3, yes. And then y1 or f of -2, in that function notation, remember you hit alpha trace, you use your parentheses, is -13.
Hey, we have opposite signs. What about f of 2 and f of 3?
So y1 of +2, or f of 2, gives me the output of -9. And f of 3, or y1 of 3, gives me an output of 27.
Hey, opposite signs again. No way. Fascinating. All right. So I'm going to have I think I'm going to do two different conclusion statements here.
I like it.
That's so low to the ground. All right. So we'll start off with this one. F of 2 and f of 3 have opposite signs. Therefore, there must be at least one 0 on the interval 2 to 3. Okay, you can say on x equals 2 to 3, whatever. Over here, we have f of -3 and f of -2 have opposite signs. Therefore, there must be at least one 0. So many words
You got it.
on the interval -3 to -2. Guys, make sure that these intervals do go kind of numerically. Numerically? Is that the right word?
In order, yes.
Yeah, they gotta be in
Smallest-
order. Don't
from
have
smallest
this
to
from like -2 to -3. That'd be backwards.
That'd be backwards.
Some of you still do that, like on our last test. Make sure you go from small to big on intervals.
That's it.
That's it.
So remember that Thursday, I'll be doing a study session since your test is on Friday from 11 a.m. to noon. If we need to review this, since you guys don't have as much homework, but we were trying to lessen up the like assignment homework and just have you do practicing your notation on one problem, get the notation down, practice on the practice test, get ready for the test. Good?
Yep.